Hey all, good morning. Let's take a minute and discuss constraints versus objectives in grading optimization. So we're just going to try and lay out how they interact with each other, which one takes priority, and how to understand how they can work and how they conflict in your model. So today's agenda, we're going to be a bit in PowerPoint and then a bit in grading optimization. And what we're going to look at is we're going to create some constraints, objectives. They might be a bit abstract in terms of them being extreme, but we're really just going to try and see how we can force grading optimization to expose how these objectives and constraints work together. So constraints versus objectives. So constraints. So you can see here the screenshot. This is all the grading objects, those default grading objects that you have in Civil 3D. So you can see from the top here, we have low points, bounded points, aligned edges, and so forth. So for the most part, all of these are, when you create that grading object and the parameters you give it, that's a constraint. So for example, with the grading limit properties, you can see that there's customized slope constraints, max slope, min drain slope. So that's a constraint. Grading optimization is looking at that as a rule, so to speak, that it needs to fulfill. And when it doesn't fulfill it, there's going to be a violation. So when the slope can't exceed 33% in the entire grading limit of the site. So that would be a constraint. Now, same thing with a building pad. You can see that you have an elevation you set, or a fixed elevation value, elevation range. So that is a constraint. On the other hand, level grading with pad is an objective. So it is going to try to do it. This is the only one that is buried within the grading objects. So everything else, when you create a grading object and the parameters you give it, or the toggles you slide, exclusive drainage on, everything, all of those are constraints other than level grading with pad, which is the one anomaly that is an objective. And we're going to look at how that objective plays with the constraints in a second here. So, and then the other objectives are within the optimization options. So this is in grading optimization. And then you have the option to set your objective weights. What do you want to prioritize? Do you want to balance cut and fill? Or do you not care about balancing cut and fill? So all of these are objectives, and grading optimization is going to try to do it. So grading constraints are paramount to the objective. Always are and always will be in grading optimization. So let's bounce into grading optimization and let's take a look at how these all constraints and objectives work with each other. So I have grading optimization here, and this is like a parking lot that I've parking lot addition I've done at my office for concept purposes. So we go ahead and optimize this here. This model does pretty well if you let it run. So most of the violations resolve, most of the drainage resolves. Things are in good shape here. So what we're going to do is we're going to add in some new elements and some new objectives and see how that plays. So first thing, let's talk about building pads. So let's stop this here. And what I'm going to do is I'm going to turn this on, make this active. I'm going to turn on my building pad, make that active. And so what I did here with my offset is I made a 10-foot elevation difference, pretty extreme. So between the parking lot and the building pad, there's going to be a 10-foot difference. So what we're going to try and do is we're going to see if the grading goes level to the pad or if there creates a separation, a reveal, so to speak, either hiding or showing some of the building pad. So let's go ahead and restart this here, and we're going to optimize. So you can see that since we have those higher priorities with the retaining wall there, the retaining wall gets much larger to try and balance things out. But you can also see that on this side here, the level with grading with pad is not fulfilling there. So, and you can see we're trending towards an optimal solution. In some cases with these examples, we won't be. But if we go to the building pad here, and you can see level grading with pad is enabled, but we do have some of that building pad is showing. So, and you can see, and then, for some of the reason that is because this slope here is 33%. So it can't create a vertical slope, so to speak. So, and then you can probably see on the back end here, let's see if we have any of it, see if it levels it in the back. Oh, yeah, it does a pretty good job on the back end, which is nice. So One trick you can do with trying to hide a foundation is you can use a reveal and make it 0 or make it negative if you actually wanted to completely hide it, or make it positive based on if you want to show it. So a couple different, so that's a building pad level grading with pad, so to speak. So how it's going to, it's not always going to work. It's not always going to work as you think it will. So for example, if we hit stop here and we restart, and then let's take this elevation offset off here. So restart, play, and then so now there's no elevation offset. So we don't. It's not that 10-foot difference between the two. So you can see here now where our priority of level grading with pad is working. It's working a lot smoother. So, but you can see how if you add in a constraint, the objective becomes second tier to it. So building pads and level grading with pad. So second thing here, let's go ahead and let's work with those optimization options and change the objectives for the cut and fill. So let's go ahead and let's just turn off this building pad here, and then let's what we're gonna do is we're gonna run the model and we're gonna watch how the cut and fill balances. So let's restart this here, and we're gonna hit optimize. We're just gonna leave it as is. So let me just turn this off here since that's no longer active. We're going to turn this off too since it's no longer active. So optimization options right here. Let's click this button. And so you can see since, if I can open that up, we don't have the cut and fill set as a priority. So you can see here our volume, it's just doing whatever it's going to do to find the, to find the quickest solution. You can see we're treading towards an optimal solution. So what we're going to do is let's flop it now. Let's crank that cut and fill objective up. So take a mental image of this right here, and then let's crank that up. So, and what we're also going to look at here before we do it is, you notice this is sloping down. This doesn't necessarily have, it just has a max slope, doesn't have a mid-drain slope set to it. But let's watch how this changes when we increase the cut and fill. So stop, let's restart this. And we're going to do balance cut and fill, and we're going to take this to 100. Keep in mind, this isn't like pizza where you 2 slices go here, 2 slices go here. It's 0 or 100, and each one's independent of each other. So we're going to set that to 100 now, and take a mental note of this right here, what it looked like before, and we're going to hit optimize. So you can see now it's sloping downwards because it's, we're trying to balance that cut and fill. So if we crack open the convergence plots here, you can see that, we are balancing our cut and fill a lot. You're seeing that, you're seeing that balance between the two that you weren't seeing when that optimization option was set to 0. So that's good. That's what we would expect. So we're balancing cut and fill. So now let's give it a constraint that will, so to speak, override this and make a constraint take precedence over that objective. So let's close this. And you can see here we're sloping down a bit. You can also see we have a bit more, a couple more violations now. Our slopes are 5.38%. And then you can also see it really raised that retaining wall to balance that cut and fill. So let's stop this here. Restart. And what we're going to do is, you can see here, if I hover over any of these triangles, that it doesn't have a drain slope towards. For that zone, there's nothing set for it. So if we click it, you can see it's set to 0. So what we're going to do is we're going to set it to 1. So now that we're giving it a mid-drain slope, it's going to have to go towards the parking lots because that's where the drain line is. So let's go ahead and let's hit play here. We're going to leave our balance cut and fill at 100, and we're going to hit optimize. So you can see we're moving up and down here. We're definitely not sloping away from the parking lot anymore. And so let's go to our convergence plots. And then what we're going to see here is we're going to see the fill become less and less and less. And you can also see where convergence plots are. We're red and orange. We're definitely at a high number. We're over 10, so that means like closer to 0 you are, the closer you are to a solution, or 100% solution. So, but you can see here we are just trending upwards as we go. So it's looking at, it starts by looking at the constraints and objectives together, but then gradually as it weighs the constraints against each other, the objectives become less important. So you can see as we keep going here, our fill volume just keeps decreasing, and our cut volume just keeps increasing. So some things to think about when you're working with grading optimization. So 4 main objectives in grading optimization. So it's level grading with pad. That's the only one that's buried in the grading objects. And then the other 3 are the optimization objectives. And one of those is the cut and fill we're looking at. The smooth surface is the other one. And then that third one is minimize earthwork. So just some things to think about, that these are objectives. They're not the priority for the solution. Grading optimization is going to try its best to accomplish it, but it may override it based on the constraints you gave it. So I want to thank you for your time, and have a great rest of your week.